Yes, hello and welcome. I'm Rosander from the company Kran Specialty Fluids, or formerly known as Temper Technology. And I will present a little bit about how to optimize your heat transfer fluid or your secondary fluid, secondary refrigerant if you want. And I will do it show in different ways by optimizing energy or materials such as pipes or air coolers. And these calculations are made by a third-party company with Mrs. Christina Nilsson, which have an MSc, Master of Science in Sustainable Energy Systems from Chalmers University of Technology in Sweden. She had made these calculations for us, and I will present what we can come through. And as I said, we were formerly called Temper Technology, but today we are in a German company called Kran, and our company is called Kran Specialty Fluids. Yeah, we have a calculation for a, say, distribution center where we have the light blue one is a cooling storage, and the freezer storage with a dark blue. And in this building, the red ones, we have a temperature of -15. The cool room have air temperature of +2 and has an area of 30,000 square meters. And we comparing propylene glycol and crane temper with a freezing point of -15. And later on, we come to a freezer storage where the area is 6,000 square meters with an air temperature inside of -22. And therefore, we use crane temper -40, which has a freezing point of -40, and compare it with monopropylene glycol. Perhaps someone said, why do you use monopropylene glycol at this low temperature? But we said, we will compare with MPG because everybody knows about MPG. So here is how the plant is looking. And as I said, the cold storage has a area of 30,000 square meters. And the surrounding temperature in the building is 15. We have installation mean value of 8.18. Refrigeration power of 217 or 168 respectively. And this is the base of what we're making the calculation from. The calculation is made in different steps because we want to optimize in different properties. First, we can optimize to have a small air fan cooler, or we can also optimize for small pipes. But the most efficient is, of course, to optimize in energy consumption. But still, we're making three different calculations and comparison. First of all, when choosing a fan air cooler, we use the parameter of less than 30 kilopascal per in pressure drop. And we do the same for temper, and later on we make the same calculations for the freeze storage. And concerning the pipe dimensions, we are having set less than 100 Pascal per meter in pressure drop, and the total pressure drop are calculated. We are doing the same then for crane temper, and later on also for the freeze storage application. We can see when all these are calculated that we have not only energy saving in the indirect circuit, but we have also, in some cases, an improved total COP also. Also, the pump energy demand is calculated for different cases, and we come to that later on. First of all, comparing the two fluids in this comparison, We have the crane temper fluid with a freezing point of -15, just like MPG, but they all normally sell it in a specific percentage. And in this case, 30% is -13 in freezing point. And the big difference in this picture is the viscosity. You see, MPG has quite higher viscosity than temper, but also the thermal conductivity is better for temper. And these you will see later on making big difference in heat transfer areas, but also in pressure drop. When calculating these optimizations, when you're calculating to optimize the energy consumption, you can see you can have smaller pipes, you can also have smaller flow because of the better heat transfer and also lower viscosity, making less pressure drops. Or in this case, you can then go up in temperature of the fluid out from the evaporator, and consequently you can also increase the temperature in the evaporator with 1 centigrade also, which earning a lot of energy. And you can see also here we have a much less pressure drop with optimizing of energy, but also you can optimizing by the area of air coolers, and you can see you have quite smaller heat transfer surfaces. But as I said, the energy consumption is perhaps the best one, because then you can also, in many cases, reduce the pipe dimension, but also the air cooler dimensions. When optimizing the pressure drop, we come to these figures. We have MPG as a reference for all these calculations. And you can see when optimizing the energy, you can go down to less than a third in pressure drop by using crane temper. When optimizing for pipe material or fan air coily surfaces, you don't earn that much in pressure drop, but of course you earn a lot in area and size. Summarizing what's happening in this cooling storage, you can see that you can earn quite a lot of energy because you have a higher temperature from the evaporator, which allow you to reduce the energy consumption in the compressor here with 5% approximately, because you can go up in 1.3 centigrades in the evaporator. So there you had a lot to earn, also in the compressor or the primary system, not only in the secondary loop. And here you see when you optimize in different properties, you can earn different amount of energy. When optimizing of energy, you can earn, here it says, 8.7 megawatt hours. That corresponds to 41% less energy consumption for the optimization of crane temper in optimized energy. And if you instead wanted to optimize in pipe material to reduce the costs of installations and pipes, you can also there earn 30%. And if you only want to optimize for fan air cooler, you can still earn a lot, 10%, compared with the MPG alternative. And here we can see what is the cost in these materials. We are adding both pipe and fan air coolers. And we got these figures. This is translated from Swedish crowns, which are at that time 10.5 Swedish crowns for €1. Today I think it's 11 or even more. But it doesn't matter because later on I explain it in what does it mean in percentage. So If you optimize temper with pipe materials, you can earn in installation cost. It should be said 20%. Something is wrong here. Sorry, 20%. And also, if you're optimizing for air coolers, it should also say 20%. I don't know why it's something different, but you see, you can earn quite a lot by using a more efficient heat transfer fluid. What has happened when you summarize this cooling storage application? Well, you can see only in pump energy consumption in the secondary loop, you can earn 41%. That means even though perhaps Temper is somewhat more expensive than MPG, in just 1 or 2, perhaps 3 years, you have a break even compared with a cheaper or less efficient fluid. So it's no excuse to say we buy the cheaper one, because in a few years you have earned by choosing Temper or another product. In this case, you also see that we can increase the evaporation temperature, in this case with 1.3 centigrades, and make the approximation that you earn 4% per centigrades in the evaporator. Here, it means in this case you can earn 5.2% energy consumption in the evaporator in total. So there are quite a lot to earn, and together with the pump energy, you can earn up to 7% in energy costs compared with the MPG alternative. And it's also say here, even if you only optimize for energy, you can still earn 16% in material, because they come hand in hand. There are also other alternatives where you can optimize for materials. Then you earn a lot in that area, but you will have a higher energy consumption. So best alternative, optimize in energy and get the others as a bonus. So if you go to the other comparison at the freezer application, we have the same fluids but another concentration, meaning that they are more concentrated. For the MPG it's 54%. Perhaps no one used that high concentration for MPG, but to make it clear to everybody what is the other fluid, it's MPG that most of people recognize. We use that anyway in this case. And for crane temper, we use crane temper -40. And -40, it stands for indicate the freezing point instead of percent, because different products have a different percentage. But freezing point is freezing point, much easier. And here we see for the MPG, the viscosity is dramatically high. In this case, it's almost that you can't use normally centrifugal pumps. You have to go to reciprocal pumps or similar, and that costs a lot, both in investment, but especially in energy consumption. I'm sorry. And also in the thermal conductivity is a quite big difference between these two products. So viscosity and heat transfer will make a big difference between these products. Here are also the summary of what happened when you optimize energy and optimize heat transfer surface. In this case, you can also increase the temperature of the heat transfer fluid and consequently also the temperature in the evaporator with 1 centigrade, which means, as we said before, approximately 4% as a thumb rule. If you want to optimize the heat transfer surface, you can do that also, but in that case, you have to increase the flow rate, and consequently, then you also have higher pressure drop, but not that high as in the MPG case. When you calculate the pressure drop, we got these figures. For the MPG in these with these operational parameters, we have a pressure drop for MPG 32, and look, crane temper optimized energy 3.9. That's enormous, the big difference with MPG. When optimizing the pipe materials and air cooler surface, the differences in pressure drop is not that big, but instead you have lower investment costs. In this case, with the freeze storage application, you see here you can even here you can even increase the temperature with 2 centigrades, meaning 8%. And that you can see also in the column with the compressor energy consumption, with 8% lower energy consumption, because you can go up in temperature compared with alternative of MPG. The pump energy consumption in the freezer application is like this, and you see it's quite lower for the crane temper optimization alternatives compared with MPG. And in energy consumption, you can earn up to 58%. That's a lot. Even in the case when you're optimizing the pipe materials, you reduce the energy consumption with 26%. It's quite a lot. Not so much when you're optimizing for fan air coil surface, but instead you have a lower investment cost for the air cooler. Here we can see also how less the investment costs are for crane temper using the optimized pipe alternative or fan cooler surface alternative, respectively. Adding these together, we can see here also the reduced pump energy is 58%, as I said before, together with lowered evaporator or compressor energy. You can together earn 10% in total energy. And that is quite a lot, and as I also say, even if you optimize by the other parameters, you can earn energy also, or more money, especially these days when energy costs are increasing every day. Here is a summary of the both alternatives. You can earn quite a lot. And if you want to learn more about this, you can come and visit us in our stand, which is in Hall 7 and stand 145. And those who are interested in the right way can ask some questions if we have the time. We don't have the time, sorry, but I came down and give you my business card for those who want to learn more. Thank you very much, and thank you for your...